Cosecant is the reciprocal of sine. So one way of finding a function for this graph, finding the cosecant function for the graph, is to find the sine wave between these points on the graph, and then you can just replace sine in that function with cosecant, and you'll have the graph of all these red curves. So in order to do that, we need to know the period, the vertical shift, any horizontal shifts that happen, and the amplitude of the sine wave. So let's start with the easiest one, the amplitude A. Oops. So the amplitude is how high is half the height of the sine wave. So -5 looks like that's the bottom. And then where do we go to? 1, 2, 3, 4, 5. So 1 is the top. So it goes from -5 to 1. That means it's got a total distance of 6. The amplitude of this thing is 3. Okay. It rises 3 and falls 3 from the midline. And we can do the midline next. The midline is what's happening with the vertical shift. We usually think about sine starting at the center and reaching its peak, then going down, then coming back to the center once it's gone through a full period. So this would be the midline of sine of x. It's the x-axis. But the midline has been shifted down. And to be sure of where the midline is, we can use what we just studied with the amplitude. The thing is 6 units from bottom to top. That means if we go 3 units down from the top, we should be at the midline. So the midline is right here at y equals -2. So we're going to do -2 for d. And if you're wondering what these coefficients are, it's from the standard form of a sine wave. It's a times sine of b parentheses x minus c plus d. Okay, it comes in different forms, but I think this is what our text is using. So a is the amplitude. We just found out the vertical shift. Let's see, next, before we do horizontal shift, let's figure out what the period is. The period is how long it takes, and note that the period is not any of these coefficients, A, B, C, or D. It'll help us determine B. But the period represents how many units we go on the x-axis before we start repeating ourselves. So we could pick any point on our graph and then find out the identical point. And it looks like it goes from x equals 0 to x equals 4 pi. My drawing's pretty poor, but that's where it should start repeating itself. So this thing has a period of 4 pi. And the period can help us find out the period can help us find out what the coefficient b is. So if you plug in 4 pi in for the period and just ignore the absolute value sign, you solve that equation, you're going to get b equals 2 pi over 4 pi, so b is 1/2. So we put this together and we're almost done. We've got a is 3, sine of 1/2, that's x minus c, and then our d is -2, so I'm going to say -2 here. So to find out what that c is, you could test out a certain point. We could plug in something that we know should be true. Like when x equals 0, the graph is telling us y should be 1, 0, 1. So if I plug in 1 for the y value, and 0 for the x value, I can distribute that 1/2. That's 1/2 times 0, so this is a negative c over 2. We want to get the sine function by itself, so we'll add 2 to both sides. And we'll divide both sides by 3. Okay, and so now the question is, what does the angle need to be in the sine function to make it equal 1? And so equaling 1 or 0 is special for sine and cosine, right? Draw your unit circle. Sine is always the y coordinates in the unit circle. So here this is 1, 0, because the unit circle has a radius of 1. So the y coordinate here is 0. Here, since the unit circle has a radius of 1, the y coordinate is 1. So we need the angle, we need this negative c over 2 equal pi over 2. So we multiply that -2 to both sides, so that's going to give you negative pi. So our final answer is this, except minus negative pi, so we could say plus pi here. And that is the sine wave. The final answer for the cosecant function that will make the red curve is 3 cosecant 1/2 parentheses x plus pi and parentheses minus 2.